Welcome. My name is Morton Barlaz, and I'm head of the Department of Civil Construction and Environmental Engineering. And I'm thrilled to be able to welcome you to a virtual tour of Fitts-Woolard Hall. I am standing at the top of the monumental staircase, which you can see on your left. We're at the top of the staircase on the third floor. The third floor is where we have all of the civil engineering faculty and staff offices, the department office, the undergraduate programs and graduate program offices, as well as the environmental engineering lab. I'm thrilled to be here. I wish we were here in person. We'll do the best we can with a virtual tour. I'm going to start by showing you around our environmental engineering laboratory complex. The environmental engineering complex includes over 11,000 square feet of space dedicated to various chemical and biological aspects of our work. The space serves currently the research programs of 6 faculty and over 50 graduate students, undergraduates, technicians, and postdocs. We have an analytical instrumentation room where we're housing our expensive and sophisticated chemical instrumentation in a room where we have excellent temperature control, as well as some unique infrastructure to support access to our instruments, as well as a myriad of gas lines to support the operation of these instruments. One highlight of the laboratory is that we have these snorkels located throughout. These snorkels provide flexible ventilation so that I can move it down to an area where I'm working and get excellent ventilation to remove gases or dust from that specific area. They're located all over the laboratory and, as I say, provide us with a good deal of flexibility. Behind me is an anaerobic chamber. We do a lot of work in which we need to maintain anaerobic conditions, and we've got 2 ways to do that. One is this anaerobic chamber, where people can actually work inside of a glove box by putting their hands through these gloves. And then we also have this gassing manifold here where I can prepare anaerobic biological medium working at this gassing station to sparge any air out of a system while I'm working. Our fume hoods all have monitors which are checking continuously the air flow rate through the system to make sure that that flow rate is high enough to remove whatever gases we're trying to vent out of the laboratory. And they're set up with an alarm so that if there is something not functioning, we'll know it immediately. We have 2 walk-in refrigerated rooms for dedicated sample storage. We have a room dedicated to our research on global sanitation. We have a room that's maintained at 98 degrees Fahrenheit. We use that for incubating reactors or operating reactors that are simulating landfills and anaerobic digesters. Of course, we have a dedicated teaching lab. We've got a very large wet chemistry and microbiology area for general lab work, and a pilot room. I'm standing in the pilot room where we're able to do things at larger scale that might be a little bit dirtier. And I'm standing next to a Wiley mill. This is an instrument that is used to grind municipal solid waste to a fine powder. Once it's in the particle size of a fine powder, we're able to do chemical analysis on very small samples. As you might imagine, this instrument gives off a good bit of dust, and we're set up with a hard connection vent pipe to the roof so that we're not releasing dust to the air during the grinding process. One nice feature in the pilot lab is we've got a bench in the middle of the floor, but that bench is flexible. In order to get power to that bench, we set up these drop-down power systems so that we can bring power without tripping hazards on the floor.
Hello, my name is Detlef Knappe, and I'd like to tell you a little bit about our new Environmental Analytical Instrumentation Lab. In this room, we house some very sophisticated equipment including gas and liquid chromatographs that are connected to mass spectrometers. Before our move to Fitts-Woolard Hall, these mass spectrometers were located in 3 different buildings, and I'm excited that they are now all in the same room, which makes our research much more efficient. We use this instrumentation to determine the quality of our drinking water, the quality of surface water and groundwater that serves as our source of drinking water, and also the quality of untreated and treated wastewater. Also, we use this equipment to assess the performance of water treatment processes designed to remove organic contaminants from our drinking water and to study the decomposition of waste in solid waste landfills. One particular area in which we are active is the detection of per- and polyfluoroalkyl substances, commonly known as PFAS. We found that PFAS occurred at high levels in the Cape Fear River. Since the publication of our findings, PFAS levels in the Cape Fear River and in the drinking water of about 250,000 North Carolinians have dropped by 99%, making the drinking water a lot safer. This accomplishment would not have been possible without the sophisticated analytical instrumentation that you can find in this room.
Hi, I'm Dr. Angela Harris, and I'm going to be talking with you about the Global Water, Sanitation, and Hygiene Research Lab and the Molecular Bio Lab. In these spaces, we are able to conduct biosafety level 2 work, where we're able to work with moderately hazardous organisms. We process many different types of specimens, including wastewater and fecal specimens, but also environmental samples, including surface water, drinking water, soil, hand rinses, surface swabs to understand the fate and transport of microbial contamination in the environment. This is one of our biosafety cabinets where we can conduct this level of work, and we also have a second one in the molecular biology space. We're able to extract nucleic acid from these different environmental samples using automated extraction equipment such as the QIAcube HT. Facilities that we have here at Fitts-Woolard Hall have now given us more space to conduct this work and allows us to have even more equipment to better improve our analytical methods for testing environmental samples. We also have a digital droplet PCR machine, which has an improved sensitivity for detecting nucleic acid signatures in our samples. We are excited to be in Fitts-Woolard Hall, where we have more space and we're able to set up equipment for higher throughput of sample processing to really improve our productivity and our research efforts to protect human health and the environment.
Research in the Environmental Electrochemistry Lab is focused on understanding and optimizing a variety of technologies that can provide a range of environmental benefits, including the removal of pollutants from drinking water, treatment of wastewater, and the recovery of resources such as energy and nutrients from waste. In the Environmental Electrochemistry Lab, we have access to equipment including potentiostats that can accurately control electrodes and allow us to understand reactions that are occurring on electrode surfaces. We use equipment like that in order to control systems like this. This is a capacitive deionization cell that's used to desalinate water. We also have access to a walk-in temperature control chamber that allows us to keep the temperature constant so that we can rule out temperature as a variable in our studies. Let me show you what that chamber looks like.
I'm standing in a lounge on the 3rd floor where students can get together in between classes, whether they're studying, talking, or perhaps waiting for an advising appointment. This lounge is right across from the undergraduate programs office and the graduate programs office. And these are the administrative suites where we'll coordinate all advising of both our undergraduate and graduate students. This is the administrative suite for the department. We've got our reception/bookkeeper area. Packages come in, and then all of our support staff are located in this administrative suite. The human resources representative, the department's business officer, as well as the people that do contract management for our external research. And then we've got the support facilities, the copy machine, storage, office supplies, and a conference room that's easily accessible to the department head's office for entertaining or meeting with large groups of visitors. Our nice new break room has lots of nice light, nice view of the engineering oval, and we even have a balcony where people can eat outside in nice weather.
Hi, I'm Dr. Jason Patrick. Welcome to the Multifunctional Composites Lab in the new Fitts-Woolard Hall. This is a 1,000 square foot state-of-the-art facility where we're developing multifunctional fiber reinforced composites for various structural applications, including civil infrastructure, aerospace, automotive, naval, and even energy components. We have two main facilities in this laboratory, one where we do microstructural characterization, material characterization, and a variety of mechanical testing. We also have a second laboratory where we do composite processing and preparation of samples for further experimentation. These spaces house a variety of different equipment, everything from 3D printers for additive manufacturing of novel materials, a microscope for structural imaging on the micro scale, a chemical fume hood for synthesis of various formulations that we use, mechanical load frames for a variety of mechanical testing and protocols to quantify the material properties, and then also fabrication equipment including composite layup stations, curing ovens, and things that you would find in aerospace and automotive infrastructure. This new facility has really helped us foster our research and propel into a new dimension with what we're developing in terms of modern infrastructural materials. The students really enjoy working here. I have a great time researching and exploring and creating with them. And we're enthusiastic about the developments we can make with these brand new facilities, and excited to see what the future holds.
Hello, I'm Serena Sowers, and this is the new Construction Engineering Lab. This space supports the research of Dr. Han and Dr. Gupta's students. We are predominantly focused on studying the behavior of small-scale structures, such as piping systems and shear buildings. Most of the research is carried out on the shake table using the function generator and oscilloscopes for measuring the readings. It aids us in the verification and validation of our numerical simulations via experimental studies.
Hello, my name is Mojtaba. I'm a fourth-year PhD candidate at NC State. In this lab, we're working on construction, automation, and robotics. And the main focus is using computer vision for monitoring construction sites.
Hello, I'm Heramb Mahajan, graduate student working under Dr. Hassan, and I'm going to show you a structural testing lab where we do material level and component level experiment. So in this particular lab, we study the material behavior through series of tests, which includes tension, creep, fatigue, and creep fatigue at elevated temperatures. So the goal is to study the material and how it's going to perform under specific load condition. And by studying that, we implement that knowledge and apply it to study how a component will be designed and analyzed. And once we design a component, we test that component for its intended load performance. So you would see a series of holes on the bolts, and those are to tie down a shake table, which we have in this particular lab to study the component performance under dynamic load condition. We will be seeing two types of test setup. First is the macro scale, where we study components and material level test setup. And the second is the miniature scale, where we study a component at a millimeter scale to study the difference of macro scale versus miniature scale.
Hi, my name is Dr. Shane Underwood, and we're in the Asphalt Multi-Scale Mechanics and Material Characterization Lab. This lab supports the Transportation Materials Group in their research studies to improve the design, construction, sustainability, and resilience of our asphalt pavement network. This complex includes more than 7,000 square feet of laboratory space. Specialized rooms in the lab include the material storage facility, where we house processed and unprocessed materials before and during testing. It also includes the aggregate processing lab, where we prepare and evaluate aggregates for later testing. We also conduct lab sessions for our undergraduate courses on civil engineering materials and our graduate courses on bituminous materials in this space. The asphalt mixing lab, where we fabricate our samples before we test them. This room houses a number of ovens for heating asphalt concrete and specialized equipment like gyratory and segment and wheel compactors for fabricating specimens. We conduct the majority of our testing in the asphalt multi-scale lab. Asphalt concrete is a composite material, and this lab has a range of equipment to probe and investigate that material at all length scales. At the largest length scale, we have the high-capacity universal testing machines. With these machines, we can test large asphalt concrete specimens as well as simulated pavement layers with interfaces. At the smallest scale, we have rheometers that can test asphalt binder alone and a range of equipment to bridge those two lengths. The asphalt mixture performance tester seen here is one instrument that we're using extensively to characterize dozens of mixes from around the world and from right here in North Carolina. The new lab facilities in Fitts-Woolard Hall have been a great improvement and offer us a great opportunity to be more efficient and effective in our testing, evaluation, and research studies.
Welcome to the Environmental and Fluid Mechanics and Transport Lab. It is approximately 2,000 square feet where faculty researchers and graduate students look at the intersection between fluid mechanics, biological, physical, and chemical processes that influences natural systems and engineered systems. One of the unique features that we have here is this Flume. It runs about 2,100 gallons per minute, and it looks at problems that involve how fluid mechanics influences our natural infrastructure. Another great feature is it's the only lab that has a 22,000 gallon tank below ground. which supports all the large-scale pilot systems that are involved in this lab.
Hello, my name is Dr. Tarek Aziz, and I'm here to tell you a little bit more about some of the equipment we use to measure water quality in the hydraulics lab. So we have a solar simulator to look at the photodegradation of various chemicals in the environment. We have a HPLC behind me here to look at measuring the concentration of those chemicals. And we have what's called a spectrofluorometer to fingerprint the dissolved organic matter and measure some of the enzymes produced by organisms like fungus in the environment so we can study how active they are. This is our hydraulics teaching lab where students learn the important principles of fluid mechanics necessary for them to design our water resources infrastructure. So over here we have hydraulic benches where students will do experiments on flow in pipes, Bernoulli's principle, and impact of jets and linear momentum. And over here we have our teaching flume where students can study open channel flows, hydraulic jumps, and flow over weirs. We're excited about the updates to this space and to allow this space to evolve over time so that our students can continue to get the great hands-on experience they need to design the future of our infrastructure.
Hi, I'm Dr. Brina Montoya, and this is the new Geotechnical Teaching Lab. This space supports the education of our undergraduates in soil mechanics. In this laboratory, we assess soil properties, including gradation, permeability, consolidation, and shear strength. Snorkels have been added throughout the laboratory to improve the air quality during soil testing. Additionally, all soil sieving now takes place in a dedicated room to ensure any generated dust is ventilated out of the lab space. In this laboratory, we can now safely accommodate more students at one time. And the lab has been designed so that lecture is integrated with our experimental activities, thus improving the undergraduate experience.
Hi, my name is Barlaz, and we are in the cementitious materials laboratory today. One of the unique features of this lab that you will not be able to see is that the foundation of this laboratory is separated from the entire building. And what that enables us to do is to have analytical equipments that are doing very sensitive measurements, such as mass measurements of less than 1/1,000,000th of a gram, or nano-indentation, where we are measuring displacement at a few nanometer length scale. This lab is not affected by operation of heavy equipment in the surrounding labs or when people walk around the building. Another feature of this lab is that it has stations for students that they can prepare their experiments or do some analysis while they are running their experiments to check the result and make sure they're on track. We have another lab that we do sample preparation. We cast concrete and cement paste and other cementitious material. That lab is equipped with a state-of-the-art curing room that is programmable, and it has a sump that is at floor level. And that enables us to utilize the entire space without wasting the space for sump. It enables us to clean it very well, and the water in that sump moves through multiple filters. In addition to that, our concrete technology lab is equipped with snorkels that we use during the casting and batching of concrete to make sure all the dust moved away from the users.
Welcome to the Student Project Space in Fitts-Woolard Hall. I'm Steve Welton, and I'm the faculty advisor for several of our student organizations, as well as senior lecturer with the department. It has been my pleasure and honor to be able to help develop this space, and we have done so with the idea of maintaining flexibility for the student groups that will use this space into the future. Those that will be using this space include ASCE, ACI, AGC, EERI, EWB, as well as the high school summer campers. The space was designed with the effort to try to maximize flexibility. You can see we have rolling tool chests where each group has their own set of tools, and these are able to be reconfigured for whatever project or demands are necessary. So they can be set up for individual groups, they can be assembled into a large area for the concrete canoe mold, or they can be pushed aside and make room for the steel bridge competition that you see behind me. We are very fortunate here to have the large windows, which provide a very wonderful opportunity for natural light, and that too provides a window into the space and the functions that we'll be doing in here to hopefully inspire other students to look into a degree with civil construction and environmental engineering.